Hi, welcome to our video lesson about symmetries in nature and art. I will divide this lesson into two videos. So for this one, the first one, it's going to be an introduction and a discussion on reflectional symmetry. So let's start with the definition of symmetry. Symmetry from the perspective of the arts refers to the balanced arrangement of elements so that one portion mirrors, duplicates, or complement another. So it creates a sense of harmony, stability, and visual appeal. So as you can see here, we have two very similar looking things. The first one is a butterfly. So they are usually symmetrical, even the color and the parts. So this one is a graph, a polar graph created by Temple H. Fay, and this is the equation. So this is a what we call a transcendental butterfly curve. So yeah, this is just an example. So we have two basic or common types of symmetry. The first one is reflectional, the second one is rotational. So we are going to cover reflectional in this video. Reflectional symmetry refers or is the most common type of symmetry found in nature and employed in the arts. It's also known as mirror symmetry or line symmetry. So it occurs when a figure or object can be divided by a line, which is what we call an axis of symmetry, into two halves that are mirror images of each other. So, for example, we have a butterfly. So, a butterfly has a reflectional symmetry because if we divide it here, a vertical line as our axis of symmetry, we're going to have two mirror images of each other. So, if we fold it, we are going to have exactly the same image. So let's have more examples. We have to identify if the given object has a reflectional symmetry. If yes, we have to identify or find all of its axes of symmetry. So let's have this one as our first example. So we have this rug or a tile with a certain pattern. So our first line of symmetry is already drawn. So if we fold it in half, you will have exactly the same image, right? As you can see here. So yes, it automatically means that this has reflectional symmetry. With regards to the line of symmetry, we already have one. Let's see if this is possible. So if we divide it into two, these are mirror images of each other. But the pattern here is not gonna have mirror images of each other, right? So it should be like this on the other side. So they don't strictly have a line of symmetry here as our horizontal line. So we have one axis of symmetry. Next. So sometimes reflectional symmetry also refers as bilateral symmetry, but in our book specifically, it refers to an axis or an object that possesses a vertical axis of symmetry. So that's what it means in the book. But by from the name itself, it's just bilateral. As long as it has reflectional symmetry, then we can say that it also has bilateral symmetry for now. So that's one type of symmetry. We also have radial symmetry. We are not going to cover this today, but just know that it exists. So instead of putting or slicing it in half, we choose a fixed point and then we divide it into how many parts that we have until we have mirror images of each other. Next, we have a semicircle. So for a semicircle, you can pause the video if you want to answer it yourself. So a semicircle has reflectional symmetry and we only have one axis of symmetry. So one AOS. And then next, let's have a rectangle. So let's draw a rectangle here and then identify the number of, or first we have to identify whether it has reflectional symmetry or not. And then from there, we identify how many axes of symmetry we have for this figure. So first of all, yes, it's gonna have, or it has reflectional symmetry, because if we slice it in half vertically, we're gonna have two mirror images of each other. And then we can also do that here. Yeah. This part on top will be the same as the bottom. So far we have two axes of symmetry. So some students might be tempted to draw a diagonal line, which kind of looks the same, but if we fold it in half, they are not gonna align, right? So you may get like a piece or random rectangle piece of paper, and if you fold it diagonally and uh if you divide it diagonally and fold it in half, it won't have the exact mirror images. So this is not an axis of symmetry. So we only have two axes of symmetry. Now let's have a square. So let's draw one. It's not gonna be perfect, but just bear with me. So we have this square. Okay. So it has a vertical axis of symmetry, horizontal axis of symmetry. This one, since this is a square, all the sides will be congruent with the same angle, which is 90 degrees. So if we trace it like so, it's not gonna be perfect, but yeah, just imagine. So yes, it has reflectional symmetry, and we have one, two, three, and then the other diagonal also. So we have four axis of symmetry. So we can draw it separately if you're having a hard time imagining. So our first square, so first axis of symmetry, second axis of symmetry, and then we have the diagonals. So here and then the other. So in total, we have four axis of symmetry. Next, let's have a scalene triangle. So what do we mean by a scalene or scalene triangle? So these are triangles for which we don't have any equal side, right? So since no sides are equal, for example, let's have this like this. So no sides are equal. So no matter where we divide it, there won't be a mirror image of both halves. So it has no reflectional symmetry. And of course, since there is no reflectional symmetry, then it doesn't have an axis of symmetry as well. So next, we also have, or we can also identify the reflectional symmetry with letters. So for example, let's have the letter A, the uppercase A. So if we look at it, let's make it bigger. And then let's type other letters as well. Okay. So here, let's take a look at each letter. So for A, we can splice it in half here, vertical, and each side will be congruent or mirror images of each other. So yes, it has reflectional symmetry, and um we have one axis of symmetry. And then next for D, we can splice it here. So it has reflectional symmetry, and we have one axis. So for G, as you may have guessed, it doesn't have a reflectional symmetry, as well as J. So yeah, that can also um, be used for lettering. Next, let's have the Philippine flag. So for the Philippine flag, with the images itself, we can say that it has reflectional symmetry here if we divide it here. So the figure on top is the same as what we have at the bottom, with regards to the images itself, right? But when it has horizontal reflectional symmetry, of course, except for the coloration. So this one is blue, this one is red. So, yeah. So it has balance, but as you know, there is meaning to the different colors, right? So it gives emphasis also. So that's one way that symmetry can be used to send a message, basically. So yeah, it doesn't have reflectional symmetry per se, but with regards to the images itself, then it has reflectional symmetry. And then let's give a summary for reflectional symmetry in different areas that we have. So just to give you an overview. So in animals, we can commonly see it. So usually even in humans, we think symmetry as perfection, right? So it allows for animals, um, it has been a product of evolution linked to improving active movement and forward locomotion. So here we have eagles, um, and carabaos, and a stag beetle. For flora, reflectional symmetry aids making pollination more efficient and contributes to better survival in diverse environments. So here, maybe you can actually try and uh splice it or get the axis of symmetry of some of these images, right? And then for flora as well, so we can divide it here. So we can say that it has reflectional symmetry. Architectural designs, reflectional symmetry is also prevalent in architectural designs as they provide extra structural support and aesthetic appeal. So as you can see here, we have this church in Surigao del Norte that shows perfect um, reflectional symmetry. We also have We also practice symmetry in traditional, reflectional symmetry in traditional Filipino textiles and clothing designs. So you can see it in patterns that we have here and also in the traditional clothing like barong and uh, Filipiniana. Lastly, for functions, even for one specific type of function, which is what we call even functions. In case you have forgotten what even functions are, you can go back to grade 10 math for polynomials. So these are functions with a property f of x is equal to f of negative x. So that means it has a reflectional symmetry with respect to the axis, or sorry, in the y-axis. So if we use the y-axis as our axis of symmetry, they are going to form two mirror images. So can you name the functions represented? So the first one is a cosine function. This one is quadratic. And then we have absolute value. So for now, you don't need to learn how to graph this one. Just know that you just need to know how to identify the or find the number of axis of symmetry. So we also have ellipse, hyperbolas, and ellipses, hyperbolas, and rational functions. So they all also have reflectional symmetry. So this one has two, this one has two as well, and this one has a diagonal axis of symmetry. So yeah, two here also. Yeah. So that concludes the discussion on reflectional symmetry. If you have any questions, you can message me or you can send a comment. Okay. See you on the next video.